Biography. Archimedes of Syracuse was a Greek mathematician who lived between 212 BC till 278 BC. Archimedes was more than just a mathematician, but he also specialized in other areas of physics, engineering, and astronomy. He is considered to be one of the greatest mathematical minds in history, alongside Sir Isaac Newton and Carl Friedrich Gauss. Some of Archimedes' greatest contributions to mathematics were in the areas of geometry, and it is also believed that he was actually the first to have developed the idea of integral calculus centuries before Newton and Leibniz. One of the most recognized contributions Archimedes had in the area of geometry was discovering the volume of a sphere and the value of pi. Further elaborating on the early discovery of integral calculus, it was believed that he had discovered what is referred to as today integration by parts or definite integration. With this study of calculus, he also devised a formula to find the area that is enclosed by a curve.
Volume of sphere. One of the most noticeable achievements was the study on spheres and cylinders. Although at the time it was nearly impossible to evaluate ratios using irrational numbers, especially when there wasn't much information about the value of the ratio between the circumference and the diameter of a circle. Archimedes was, however, able to highlight the relationship between the volumes and areas of various geometric shapes. Some of these works managed to give the formula for the volume and surface area of a sphere. Archimedes began with balancing a cylinder, a sphere, and a cone. Archimedes was able to state that the density of the cone is 4 times the density of a cylinder and the sphere. He then imagined taking a circular slice out of a sphere, delta x, and then hanging the cylinder and sphere from a point and suspending the solids at the fulcrum point. With this in mind, Archimedes was able to show that the cone and the sphere balance 4 cylinders. He then integrated one of his other discoveries, the laws of the lever, by using the following equations.
Integral calculus. The history of calculus dates back to over 2 millennia by an ancient Greek astronomer known as Eudoxus. This technique was first documented in a systematic way of determining integrals by a technique known as the method of exhaustion. The basic way of understanding this method is to take a shape whose area needs to be calculated and dividing it by pieces whose area has already been calculated, hence by making the division smaller and finally exhausting the area not included. Eudoxus used the method of exhaustion by finding areas and volumes of shapes by breaking them up into infinite number of shapes for which the area and volume was already known. The method was to be developed even further by Archimedes to calculate the area and volume of far more complicated shapes such as parabolas and the approximation of a circle. The method of exhaustion was how Archimedes also obtained the volume of a sphere to be 4 times that of a cone, having a base and a height of the same radius. Archimedes found his interest in calculus by finding the area enclosed by a curve. He did this by taking a rectangular segment under and finding the area of the rectangle and adding them together. This method of calculus is more commonly known today as integration by parts or definite integrals. Unlike indefinite integration, definite integration has a start and end values. This is known as an interval. The following is an example of integral calculus. With regards to figure 1.0, in the case of definite integrals, the arbitrary constant c will cancel out, therefore it can be ignored. The answer can be checked by calculating the area of the shape. And if one looks further to figure 1.1, we can see that the area of the shape 3 as is shown in figure 1.1, which is the same as we calculated using the method of integration.
Conclusion. Archimedes was one of the greatest mathematicians in his generation. From establishing the law of spheres to the discovery of the principles of displacement via the help of the hot tub, he laid down the foundations of mathematics for the years to follow. This presentation has highlighted some of the key concepts. The law of spheres, for example, enabled him to establish the relationship between volumes and areas of various geometric shapes. His development of Eudoxus, methods of finding the areas, volumes of shapes, was exceptional, as it is allowed for more complex shapes, areas, to be calculated. Eudoxus' method of exhaustion was developed further, with the help of Archimedes, into integrated calculus. Considered by many as the godfather of integral calculus and the father of mathematical physics, Archimedes was pivotal in the progress mathematics made from 287 BC onwards. His vast knowledge and expertise in the mathematical physics make Archimedes undoubtedly one of mathematics' icons in history.